What's the key to next-gen AI? Today, I'll talk about NVIDIA's H100 GPU and, of course, the amazing NVLink technology. Ever heard of massive AI models? Some have over 1 trillion parameters. Think about ChatGPT at an even larger scale. How do big tech companies handle that load? NVLink is a major reason. It's like how Tesla shook the electric car market. NVLink offers far more bandwidth than regular PCIe. This lets hundreds or thousands of GPUs operate as one. That's a big deal for next-level AI infrastructure. Why do we need faster scale-up interconnects? AI models keep growing. They now pass 1 trillion parameters. When GPUs share huge amounts of data, slow links become bottlenecks. That's why NVIDIA R created the 5th generation of NVLink R. It's built to handle massive AI models at high speed. In short, it narrows the gap between enterprise servers and exascale supercomputers. Imagine each GPU as a puzzle piece. If they exchange info slowly, the puzzle drags on. But with 5th gen NVLink, it's like having a super-fast courier. GPUs barely wait around. This NVLink version also improves scalability. For instance, a single NVIDIA Blackwell Tensor Core GPU can connect up to 18 NVLinks. Each runs at 100 GBs, so total bandwidth is 1.8 TBs. That's twice the previous generation and 14 times faster than PCIe Gen 5. 14 times? That's like going from 10 MAF to 140 MAF all at once. Systems like GB200 NVL72 use this power. DGX systems already linked multiple GPUs like Lego blocks. Now NVLink takes it one step further. CXL may get hyped too, but NVLink really shines for HPC and AI right now. What does the NVLink switch do? NVLink alone supports up to 1.8 TBS of GPU to GPU speed. But what if you want to connect an entire rack or several racks? Enter the NVLink switch. This switch helps each GPU tap NVLink's full speed. Imagine every GPU has a direct line to every other GPU. It also includes NVIDIA Sharp. That protocol speeds up tasks like data aggregation and reduction. Take the NVL72 system as an example. It pushes GPU bandwidth to 130 TBs, while 130 TBs is massive. Think about transferring countless HD videos in just 1 second. The switch has 144 NVLink ports. It offers a 14.4 TBs switching capacity. In a GB200 NVL72 rack, you get high bandwidth and low latency. Basically, multiple nodes feel like a single giant GPU. Enterprise markets tackle more complex tasks. HPC labs race toward exascale. Cloud providers see AI requests skyrocketing. All of them need a fast and stable GPU interconnect. The NVLink switch can link up to 576 GPUs in a non-blocking fabric. Each GPU pair communicates at 1,800 GB/s in an all-to-all setup. A single GB200 NVL72 houses 72 GPUs. It acts like one huge accelerator. It can reach 1.4 exaflops in AI compute. Exaflops means 10 or 18 operations per second. That's a mind-blowing number of calculations every second. NVLink and the switch aren't just hardware. They integrate with NVIDIA AI Enterprise and the NGC-TM catalog. In other words, you can train a model in your lab, then deploy it in production without a huge gap. Yes, it's pricey, but if your projects demand multiple GPUs, it could be worth the cost. Tesla changed the auto industry with battery breakthroughs. Likewise, NVLink is reshaping AI data centers. Why do LLMs crave multi-GPU power? Models like GPT and ChatGPT grow bigger every year. Larger models mean heavier compute loads. To keep latency low and serve many users, multiple GPUs must work together. Even if one GPU can hold the entire model, token generation speed depends on total compute. Multi-GPU can boost tokens per second drastically. For example, jumping from 5 tokens sec to 50 tokens sec feels worlds apart for the user. Tensor parallel TP inference splits each model layer among 2, 4, or 8 GPUs. After each GPU finishes its part, they must exchange data in an all-to-all. If that step is slow, GPUs end up idle. Consider Llama 3170B. It might require up to 20 GB of sync data per GPU if you have 8K input tokens and 256 output tokens. And batching multiple queries increases that load even more. Hence the need for high-bandwidth interconnects like NVLink. How does NVSwitch boost multi-GPU inference? With NVSwitch, all Hopper GPUs in a server communicate at 900 GB/s each. They all get that speed simultaneously. It doesn't narrow down. Point-to-point is cheaper. But it splits 900 GB into smaller links. so speed drops when more GPUs talk at once. NVSwitch, however, gives each GPU the full 900 GB access at once. Imagine sending 20 GB of data. A slower architecture might take 150 meters. NVSwitch can do it in 22 meters, or in 150 meters versus 22 meters is a huge gap. One is enough time to blink twice, the other is barely a blink at all. Internal tests suggest NVSwitch yields a 1.3x to 1.5x advantage in real-time LLM inference. For instance, 1.3x can shave off minutes on a 10-minute job or seconds on smaller tasks. With larger batch sizes, that advantage grows. LLMs now exceed 1 trillion parameters. HPC and AI labs need even stronger interconnects. NVLink and NVSwitch evolved to support bigger GPU domains. In the NVIDIA Blackwell architecture, each GPU can hit 1/800 GHz in NVLink speed. That's 30 times faster than some older setups. 30 times? It's like cutting a day-long job down to under an hour. The GB200 NVL72 ties 72 GPUs and 36 Grace CPUs into one rack. They operate as a unified block. This handles real-time giant models. Finance, healthcare, and global chatbots all benefit. Yes, these systems are expensive, but time is money, and scale is money. Just like Tesla's battery revolution changed everything. NVIDIA's NVLink and NVSwitch reshaped the AI ecosystem. Maybe you prefer CXL, or maybe NVLink seems stronger. Regardless, fast GPU interconnect is the key. It opens new horizons for AI. Feel free to share your thoughts in the comments.